Alright, today we're going to look at the extension from the kinetic energy and the gravitational potential energy. So these two types of energy together they are called the mechanical energy. So for a mechanical system where the total energy consists of these two energy, we can say that the total energy equals to the kinetic energy plus the gravitational potential energy, provided that there's no extra energy sources. So for example, there's an engine that is converting the chemical potential energy into the addition of these two. So there's no engine, for example, and because of that, we can say that the total change of these two types of energy is zero. And if we rearrange that, we can see that an increase in one type of the energy will mean that the other type of energy is decreasing. So in this line here, we can see that the change in the kinetic energy equals to negative of the gravitational potential energy. So that means that when gravitational potential energy decreases, kinetic energy will increase, and the other way around. Okay, so we're going to look at some example of mechanical energy system. So this is a skateboard here that I'm going to show you some positions where the gravitational potential energy and the kinetic energy are converting to one another. So take the starting at point A, that gravitational potential energy is 10 joule. Just for an example, it's 10 joule, and before it get moving, it will be 0 joule of the kinetic energy. And at point B, where it's at the lowest point in this well here, that kinetic energy will be taking all the total amount, that is the 10 joule just now as starting. So the gravitational potential energy will be 0 joule, and as it reaches the other end there, that is stopped for a while on the top, so the potential energy will be again become 10 joule, and kinetic energy will become 0. Okay, so at other instances, of course, the two types of energy will have certain values. So for example, at position D, you have 5 joules of potential energy and 5 joules of kinetic energy, and potential energy at point E will be 6 joule, and kinetic energy will be 4 joule. So if you look at the flow of it, A, D, B, E, C, A, then followed by D, then followed by B, then E and C. So as potential energy decreases from A, kinetic energy will increase to maximum at B, and then potential energy will increase again as it go up, and kinetic energy decrease in the same time. Okay, so these two types of energy, they are converting from one another without any extra source that add in the energy or causing the loss of energy. Of course, we are assuming that the frictional force is negligible here. If not, then it will also become part of it that trying to share a portion of the energy to become heat energy that's not recoverable. Okay, so something that is trying to perform a free fall, this guy trying to jump into a bucket, I mean, that's the joke. So the gravitational potential energy become smaller as it go down, and kinetic energy increases as in the same time. So the total of these two values, like the case just now, they should be the same as the initial value of 10 kilojoule here. Okay, and the case of the pendulum, we have seen this in the previous topic in dynamics, I think, that the conversion of kinetic energy and potential energy is in the process as it move from one point to another and come back to the highest point in the oscillation. Okay, so that process will continue, ignoring that the air resistance that's trying to take away the energy. Alright, so let's look at one example here. 3 kg ball falls for 4 meter. How fast is it going just before it hit the ground? Okay, so we have a ball here. Sorry, let me change the color. Alright, so we have the ball falling for 4 meter from the highest point. So it has a gravitational potential energy converting into the kinetic energy. Alright, so therefore we can write that the gravitational potential energy mg h equals to half mv square. Basically it's the change in the half mv square. So we have the m cancelled off, and we have 9.81, and we have the change of height, which is 4 meter, and we have the change of the v square. V square is the unknown minus the initial value of 0. M has cancelled off, huh? Then you should get the v. Alright. Okay, next one. Alright, this question, it should be your assignment question, but let's try to look at it first. I'm trying to explain a bit here. That we have a bullet, okay, traveling at 300 meter per second, penetrate a block of mass. So this block of mass is resting on a frictionless plane, so there's no friction here. It embed in here, and then it will slide up an inclined plane. Okay, so that's the case here. It will slide up an inclined plane. So later they're going to go up together. Alright, so this question will need you to apply the principle of conservation of momentum for the first part of the question, and the second part of the question you can use the conversion of kinetic energy and gravitational potential energy. Okay, so I'll leave you to that.